Hello everyone. Today we're going to dive into how to implement Statistical Process Control or SPC in your organization. SPC is another powerful tool in total quality management that uses statistical methods to monitor and control processes. When implemented effectively, SPC can help you reduce variation, enhance efficiency, and ensure consistent product or service quality. To make this actionable, I'll break this discussion into 5 key steps. Understanding SPC basics, identifying the right processes, selecting metrics and control charts, collecting and analyzing data, and taking action and sustaining improvements. Let's get started. SPC revolves around the concept of variation. Every process has some degree of variability, but our goal is to distinguish between 2 types: common cause variation and special cause variation. Common cause variations are natural variations inherent in the process. Special cause variations are unusual or unexpected variations that need investigation. SPC tools like control charts help us visualize these variations. For example, consider a manufacturing process that produces screws. If the diameter of the screws fluctuates slightly within acceptable limits, that's common cause variation. But if one batch is significantly larger or smaller, that's special cause variation, which warrants immediate action. The main goal of SPC is to keep processes stable and predictable by identifying and eliminating special causes of variation. Before you start using SPC, you need to identify which processes to monitor. This involves prioritizing critical processes, mapping the process, evaluating current performance, engaging stakeholders, assessing process complexity, and determining process stability. First, focus on processes that are directly linked to customer satisfaction, regulatory compliance, or organizational goals. For example, in a hospital, patient wait times or infection rates might be critical metrics. In manufacturing, it could be product defect rates or equipment downtime. Identify the processes that, if improved, will have the greatest impact on quality or efficiency. Next, use tools like flowcharts, process maps, or value stream mapping to break the process into individual steps. This helps visualize where problems might occur and ensures everyone understands how the process operates. For example, in a retail setting, you might map the customer checkout process, identifying touch points such as scanning items, processing payments, and bagging products. A software company could map its development process to pinpoint where defects are introduced, such as during coding, testing, or deployment. Gather baseline data to understand the current state of the process. Ask questions like, are there frequent defects or delays? Do customers frequently complain about this process? Is this process meeting internal or external specifications consistently? For example, if a restaurant experiences frequent complaints about long wait times, gather data on how long customers typically wait during different times of the day. Involve team members who work directly with the process. They can provide valuable insights into pain points and improvement opportunities. For example, in a logistics company, warehouse staff can help identify bottlenecks in the order picking process. Consider whether the process is simple or complex. Complex processes with multiple inputs, outputs, or steps might require deeper analysis before applying SPC tools. For example, a pharmaceutical company might analyze the complexity of its drug manufacturing process to identify key stages where quality control is critical. Before applying SPC, determine whether the process is stable enough to monitor. Processes that are chaotic or frequently changing may require initial stabilization efforts. For example, a startup experiencing rapid growth might first need to stabilize its onboarding process for new customers before implementing SPC. By prioritizing critical processes, mapping them effectively, evaluating performance, engaging stakeholders, and assessing stability and complexity, you'll lay the foundation for successful SPC implementation. The next step is to decide what to measure and how to measure it. This involves 2 major steps. First, defining your metrics. Choose measurable characteristics that reflect process performance. Here's how to choose the right metrics. Relevance. The metric should directly impact the goals of the process. For example, in a call center, average call handling time is a relevant metric for efficiency. Quantifiability. The metric should be measurable. Metrics like defect rates, cycle time, or customer satisfaction scores can be tracked and analyzed. Customer impact. Prioritize metrics that influence customer experience. For instance, on-time delivery rates are crucial for logistics operations. Historical data availability. Ensure the metric has sufficient historical data for meaningful analysis. Ease of collection. Select metrics that can be gathered without excessive cost or effort. For manufacturing, some examples are defect rates, cycle times, throughput, and product dimensions. For healthcare, patient wait times, medication errors. For sales and services industries, customer satisfaction scores and call handling times. The second major step is to choosing the right control chart for each of your metrics. A P chart is for monitoring proportions like the percentage of defective products. X bar and R charts are for monitoring averages and ranges in continuous data. C charts are used for counting defects in a fixed sample size. For example, if you're monitoring defective widgets in batches of 50, you'd use a P chart. If you're measuring the weight of each widget, you'd use an X bar chart. Once your metrics and charts are defined, it's time to collect data. Here's how to proceed. 1. Set up data collection. Collect data in real time whenever possible. For example, use automated systems in manufacturing to log defect rates or dimensions. Ensure consistency by training employees on proper data collection methods. 2. Plot control charts. Start by plotting the initial data points on your control chart. Calculate the process mean, center line, and control limits, UCL and LCL. 3. Interpret the charts. Look for patterns like points outside the control limits or consistent trends. Example 1. In a call center, if the average call time suddenly spikes above the UCL, investigate the cause. Perhaps a new software update is slowing down agents. Example 2. If a manufacturing line shows a downward trend in defect rates, confirm if recent process improvements are working. SPC is most effective when it leads to action. Here's how to implement and sustain improvements. 1. Investigate special cause variations. When a point falls outside the control limits, conduct root cause analysis using tools like Fishbone Diagrams or the 5 Whys. For example, if a bakery notices frequent overbaked products, investigate oven temperature settings, ingredient variations, or errors in the documented process. 2. Implement corrective actions. Fix the root cause and monitor the impact. For example, after finding that an assembly machine is misaligned, recalibrate it and recheck the defect rate. 3. Standardize processes. Once the process is stable, document the improved procedures and train employees to follow them. For example, if a restaurant stabilizes meal preparation times, create a standardized workflow for kitchen staff. 4. Continuously monitor and improve. SPC is not a one-time activity. Continue to monitor processes using control charts and look for opportunities to further reduce variation. For example, in a transportation company, even if delivery times are stable, investigate if you can further reduce them. 5. Communicate results. Share control charts and improvement outcomes with your team to build a culture of quality. In summary, implementing SPC involves the following. 1. Understanding the basics of variation and control charts. 2. Identifying critical processes to monitor. 3. Choosing the right metrics and control charts. 4. Collecting and analyzing data. And 5. Taking action to eliminate special causes of variation and sustaining improvements. By embedding SPC into your daily operations, you'll create a foundation for consistent quality, higher efficiency, and improved customer satisfaction. Now, where do you see SPC fitting into your processes? What challenges do you anticipate in implementing it? Check out our other training videos in this series where we continue to delve deeper into the 6 pillars of total quality management, as well as tools, benefits, and how to implement TQM in your organization. Thank you for joining, and don't forget to subscribe for new videos from All Things Quality.